Hello everyone, let me introduce myself. I'm Matteo Andreottola, I'm a structural engineer. I worked for a few years as a structural engineer for a local company which produces and designs CLT structures. And currently I'm working for Rothoblaas as a technical consultant. Let's have a look at the lesson of today. Today we're going to talk about innovative connections for CLT structures. And let's have a look at the index so that we have a rough idea at what we're going to see in the lesson of today. We're going to start off with some innovative angle brackets, which are the ones that are most commonly used right now for CLT structures. And then we're going to move on to the base connection for the CLT structures, which is the ALU START. This is a very nice innovative product. And to finish off, we're going to have a look at other couple of products, the slot for shear connections of CLT panels, and the spider and pillar. Now, let's finish with the talking, and let's move on with the presentation. So let's do a little bit of introduction of how the timber structure works for horizontal loads. So we have multiple shear walls in our structure that withstands all the horizontal loads of the structure. And as you know, CLT is a quite new product which has a lot of very good characteristics, and so the product itself is very well performing, and the only thing is that we have to connect it properly. So how did the standard approach to connecting the CLT walls worked in the past? The standard was like you can see here, having 2 hold downs, one at both ends of the CLT wall panel, and a shear connection in the middle, as you can see here. Now we are moving on to, as you will see in the presentation, we are moving onto different kind of connecting the CLT panel, and in particular we have the same connector which can be used as a hold down and as well as a shear connector. So we'll see in the presentation how that works and why it's a better in a way it's a better approach to the issue. So in a CLT building we have a lot of different connections. So connection between CLT wall panels, floor panels, and so on and so forth. In this lesson, we are gonna explain some of these connections, and I hope that you will be able to better understand and better you'll be able to better pick choose the right product for one connection or the other. So just again to start off, the timber industry is moving on, as like in the past we were used to see this very small timber structure like the one that you can see here in the picture. So like this small constructions, small structures like this mountain hut, for instance. And nowadays though the CLT structures are becoming or make it possible for us to build very high buildings, multi-stories building like the one that you can see in the pictures. Like for instance, the tallest one in Norway, for example, that is 18 floors, or the Haho Tower in Austria, which is 24 floors. And usually these very tall buildings, they have, as I said before, the main issue are the connections, really, because you have these really high forces, these really big forces, especially on the ground levels. You have big forces, and therefore you need as well some big connectors to withstand those forces. In the pictures here, you can see some of the connectors that were used in the tallest building, the tallest CLT structure in Italy, which is in Rovereto, and it has nine stories. And as you can see, it wasn't possible to use standard connections for these ones in particulars. They needed to use this customized steel steel plates, for example. And of course, this kind of plates are very expensive. They're not certified, so we're gonna see some of the connections that are available in the market and are already certified, and hopefully we'll manage to understand how to use them as well. So let's start with the modern angle brackets. Angle brackets have been on the market for a long time, for many years. But as time passed and as CLT structure became more and more popular, as well, those plates became more engineered. They developed as well. So let's have a look at what we achieved through some through the years. So this is like a standard connections, and as I was saying before, this in particular is a connection that you can use for as a hold down for tension forces, and you can use the same connection as a shear connection for the walls, for example. And we're gonna see how that's better. This one in particular, it has 5 millimeters diameter holes, and therefore you can use nails or screws depending on the which one you prefer to use, first of all, and depending on the resistance that you want to achieve. The resistance that you get with these connectors is roughly 46 kilonewton for is the timber resistance for shear, and 68 kilonewton the characteristic tension resistance of the panel. And in particular, it's interesting that just by adding this steel plate here, which is called a washer in this case, by adding this one into here, you are able to use this one, the same connector as a hold down to withstand the tension forces onto the ground level. So of course the connector has an eccentricity, and therefore it tends to rotate, and it tends to fail. The steel tends to bend up and fail, and therefore by adding this reinforcement, this base reinforcement, it's possible to increase a lot the resistance of this connector, for example. And of course you can use the same one, exactly the same one, to withstand the shear forces. And there is a very similar connector, which is the shape is exactly the same, apart from the size of the holes. This one in particular, it has 8 millimeter diameter holes, and therefore you can use bigger screws in there. Why is it better to use bigger screws rather than small nails? It depends, of course. It's a choice of the designer. But of course, when you have less screws to place in, bigger screws but less of them, you spend less time on site screwing it in. So that's an improvement on site, of course. It works just in the same way. We have the washer that can be placed for tension forces, or we can use it without washer to withstand the shear forces. So it is better, as we said before, because you can just use a simple drill to place the connector on site. This reduces a lot the noise and the vibrations that you have on site, and as well it can be faster, as we said before. That's another very well designed CLT connector. And why is it a good connector from an engineering point of view? So, as you can see here in the image, we have a series of full threaded screws that are placed exactly where the corner of the bracket is. And that's very good because it decreases a lot the eccentricity that you have on the connection, of course. And by reducing the eccentricity, you create less bending moment, and the less bending moment means that it's working better. The connection works better, and you have more resistance. In fact, it's stunning the resistance that you get with these connectors here, and it is roughly 100 kilonewton of tension. So that's really a lot. That's actually more than what you achieve with the the standard very long connectors like the WHD that we provide as well. And it has a very good, as you can see here, a very good resistance to shear as well. So it's definitely something very good, and it has some other very important characteristics. Just one of them, you can see it just right there in the corner. Sorry, you can see it right there in the corner. And as you can see, for standard hold down, for example, you need a threaded bar that passes through the CLT floor panel. And in this case scenario, as you can see here, you don't need the bar here, but you just have the screws, the inclined screws that are doing exactly the same thing. So they are resisting the tension forces. And why is that an improvement? Because as you can see in the image, for example, if you have a different thickness of the CLT panel on the upper floor, which is something very common because, of course, since you're going up with your constructions and you don't need such a big thickness because the loads are decreasing. And so that's something which is very, very helpful in multi-stories building, for example. And another very, very good thing is that in this other image, it's very clear. This connector stays under the finished floor level that we have on the inside. So if you want to have a visible facade, a visible CLT panel, you can use this one without any problems. And usually the holes down are longer, and of course, if the panel is visual, it's a problem, of course. Another thing, of course, that you can use the same connector for shear forces and for tension forces, which is something that makes everything simple, because you don't have to pick the right connector. You just have a bunch of them, and you can use it all of them throughout the building. These are some pictures of the testing that was done for these products, and as you can see here in these images here, the failure occurs where the nails are. That's a very good thing for the ductility of the connection, and we're gonna explain that further on in the presentation. And another important thing, since the connection can withstand tension force and shear forces as well at the same time, you have a domain of resistance, in which, of course, if you are inside the domain, your connection is verified. Otherwise, it is not verified. So as we were saying before, the ductility of the connection is very important, because as you all know, timber is a very strong material. It's very lightweight, and very the resistance is very high. The only issue that we have with timber structures is that timber is a fragile material. So when it fails without yielding or bending too much. When the failure occurs, it just snaps completely, like if you're snapping a branch, a wood branch in the forest. And of course, we need this ductility of the connections when we are designing, a structure which is in an area where the seismic action is quite strong, because by displacing the connection, like we can see in the image there, a lot of forces goes in here, and it makes your structure was as a ductile structure, which is very important. So let's start talking about the connection starting from the ground. And I have two examples right here of ancient timber structures which came to our days without, you know, being destroyed, without being, you know, damaged by the rain or the humidity. And that's because once upon a time the people were, of course, very intelligent in constructions. They know how the material behaved, and they were trying to achieve the best things out of every single material. And in this case scenario, for example, you can see that the base of the structure is done with stones, and just the upper part is done with a timber structure. And as you can see, all the timber structure is completely covered by the roof, and the durability of the structure increases a lot. So that was just an example to highlight that it's very important to design in the right way the connection to the ground. And that's exactly what we're going to talk about in this other part of the lesson. So water and humidity is the worst enemy of your timber structure, and especially in the ground connection is where you have to be the most careful, of course, because you have the water that tries to go up the structure, you know, because of the capillarity, and as you have as well the water from rain, which is trying to get into the structure. So a very common detail that you can see in CLT structure is this this concrete wall that you have on the ground. This is very cheap and works very well. In fact, you can see it. It's very common. You can see it in many structures. And the common rule that we have when we are designing these details here is that the finished floor level of the, you know, of your structure of your building should be lower than the dimension where the CLT wall is starting. So the only issue that we have usually with these little concrete walls is the fact that the tolerances of the concrete walls are not exactly the same as the tolerances that you have on your CLT structure. You use CNC machineries to cut your CLT panels, and you just pour on site the concrete wall. And therefore, sometimes you have big issues because they are not perfectly aligned, and that's a big issue for connections, and also sometimes for the resistance of the wall, which is not bearing completely on the concrete wall. So an improvement is this product here. This is called Alustart, for example, and it's an aluminum extrusion with some small holes on the side, right here, for nails, for shear forces, and bigger holes here, which are needed to attach this extruded plate to the concrete that you have on the bottom. You can see a better image of the product right here. And as you can see here, you can use full nailing or partial nailing, depending on how big your force, your shear force is. And it's very nice because you have this jigs, and they come in two different shapes. There are, for example, the corner ones, and the most simple one, which are the linear one. It's these things here are dimes, and are needed to adjust the height of this little of the Alustart, so that you're sure that you're perfectly aligned with your upper CLT structure. So you avoid completely the issues that you had before with a concrete wall. The tolerances are exactly the same, so you can be very precise with these things as well. And the other good thing is that you can take out the dimes here, and you can reuse them for other structures, for other jobs. So you can see here an example of how to place this Alustart. You can adjust it in on the two planes, so a longitudinally and as well laterally, like you can see in this other image. And to make sure that your Alustart stays exactly flat, you can use little timber or other materials to fence it off, and you can pour non-compressible grout on the inside, so that you're sure that your connection is completed. And once it's completed, you can remove the dime, as we said before. And we have as well on the Rothoblaas website, it is available the DWG and all the drawings of this product. And of course, we have different dimensions of Alustart, so that you can use the same product for different thicknesses of your CLT panels. And there are a few products that you can use together with this Alustart. As we said before, you can use the small nails or the screws for the shear connection, and to connect the Alustart with the concrete foundation, you can use mechanical anchors or expansion mechanical anchors. By the way, also for what concerns the connection to the foundation, depending on how big your force is, you can use a partial you can use a partial connection, and you cannot waste, and in this way you can reduce the waste of connectors that you use in the building. And why is it a good connector, this one? You are really trying to minimize the quantities of connectors that you use in your ground connection. So as you can see in the image here, it is not mandatory to use angle brackets for shear, because of course the shear is supported by the Alustart itself, so you don't need all those angle brackets, but you just need the hold downs here to withstand the tension forces. And so tension forces and shear forces. So there are three kinds of resistances. The first one is the timber side resistances, that is given by the nails or the little screws that are connecting the aluminum profile, extruded profile, to the CLT panel. Then of course you have the resistance of the material, which is aluminum, of course, and you have the resistance of the connection to concrete. So the final total resistance of your connection would be the lower one among these three that we just explained. And let's have a look at the compression resistance that you have onto your Alustart. Of course, it's a connection that you find at the base of your structure, so it has to withstand high compression loads. And as you can see here, it can withstand 721.9 kilonewton per meter of compression. So it's quite a lot. So that means you can use it. You can use this kind of connection with multi-story buildings, no problem. and it's very time effective. You can reduce a lot of time that you need to do this kind of connection on site, because as we said before, you're reducing a lot the connectors, you're very fast and very precise, and you don't have to pour concrete on site with issues on tolerances and so on and so forth. So it's very good for this case scenario. And of course, just by adding hold downs, you manage to withstand all the forces that you have to support at the base of your connection. Here you can see some pictures done on site with the Alustart. You can cut it with a regular circular saw, and you can see here details of the connection with the membranes as well, and of the little jig that helps you placing the alu in the right place. Let's move on to another innovative product, which came out on the market in the last few months. This is the slot connector, and I will try to explain what is its use, its applications, and why it can be a very interesting product in CLT structures. So of course, when you're designing your CLT structure, you might have very long panels, for example, very big wall panels, or very big panels in general. Of course, sometimes it is an issue to produce such big panels in the factory, or even transporting them might be a big issue. So sometimes you have a job which is maybe up the mountain with a very narrow road, and you have to divide your panel into small little units. So of course you could stitch together again all these little parts of your panel by using simple screws. That of course you need a lot of time on site to do this kind of job, and as well you waste time and also man hours on site, which is not usually a good thing, cost-wise as well. So what this product actually does is, it connects one panel to the other, so that instead of having a lot of connectors, you need just few of these slot connectors, which of course have a higher shear resistance. You can see here some of the most common connections that you have for CLT, connections, panel-to-panel connection, let's say, and of course we want, as you can see here, we want our panel to behave like a single unique panel, and not as a double, panel like that. Why is it the case? Because if you have a panel which behaves like a single one here, you can just place a hold down in here and another hold down in this position. If you have a panel that works like this one, you need more hold downs, because this is not behaving like a single shear wall. So that's very important. You can see here some images of the testing that was done for this product here, and you can see the resistances that in this case came out, 40.6 kilonewton of shear resistance. Of course, as we will see in the next slides, we'll see how to calculate this resistance, and what are the factors that changes how the product is behaving. You can see here what we just explained before, that we are trying to avoid having a lot of single units like that, but we are trying to achieve having a big wall that is behaving all in the as a single one. And if you have longer walls, of course, you won't have such big tension forces at the ends of your walls, and in this case scenario you will as well reduce the tensions and the dimensions of the connections that you need. This is a drawing of the product, and of course the product itself does the job, the shear resistance here, and it is mandatory to place this extra screws here, so that first of all the aluminum extrusion stays exactly where it is put, so it doesn't move, and second of all you have a little bit of resistance as well, a tension resistance between the two panels, which can be useful sometimes. And this connection here is time saving as well, because again it's the same concept. Instead of using a lot of different connectors, of little small connectors, which is very time consuming and not really much cost effective on site, you're using less of those connections, and you use connections, of course, with higher resistance. If you go on the Rothoblaas catalog, you can see this example here, and it was calculate how many nails or how many screws you need to achieve the same displacement of the wall with the slot connector or the screws. And of course you have very many screws and just few slot connectors. And here you have a table of the resistance that you have with this product. Of course, the resistance depends a lot on the since of course the area that is supporting the load is mostly the one where the fibers are perpendicular to the I mean parallel to the force. All the places where the grain is perpendicular are not so are not resisting just as much, and so just by calculating the area where the grain is parallel to the force, you can easily calculate with the tables provided how much is the resistance of this product. And you can use it, as we said before, on wall panels, but as well on floor panels or on curtain walls, for example, on big multi-story walls like the one you can see in the image. We are gonna have a look now at another innovative product, the spider. It's called spider because it reminds a little bit of the animal, of course, with all those long arms. And I'm gonna tell you where the idea of this connection came from. So it is something that comes from the concrete buildings, of course. It's very common to have concrete buildings where you have a continuous concrete slab which is supported by pillars, by columns, without having you know, a secondary structure made of beams and stuff. So like the one, basically like the one that you can see here in the corner, without any beams and nothing else. The issue that you have on these structures here is the punching through, as you can see in this little sketch here, or in the sketch that you have right there. So basically what engineers came up with are this reinforcement for concrete, and basically this reinforcement were you know, developing in every single direction so that they could take the punching shear in the concrete structure. So with the CLT structures, we try to achieve the same thing. Of course, it's very common to have structures like the one that you can see on the image now, with secondary glulam beams, and but you can decide to remove completely all those secondary beams to to have a finish, to have a structure that looks like the one in the picture right now. This is a very famous building in Canada, Brock Commons, and this is, for example, a structure that was developed using the same concept without without having any secondary beams in the building. Let's have a look at how the connector works. First of all, how the loads are going into our connection. Of course, you have the load that comes from the upper floors, which is going down here, and you have as well to add the load from the CLT slab, which is the one you can see right here. You have, of course, these very long full threaded screws, which pretty much are, of course, attached to the CLT floor panel. And pretty much how this works is that your CLT floor panel is attached with these inclined screws to the arms of our spider connector. And so these big arms are bringing all the forces down here, and so the total load is is the loads from the upper stories plus the loads from the CLT slab. And as well, these connectors here, the full threaded screws, the inclined ones here, are very useful for another thing as well, which is the rolling shear. Of course, in a situation like this, one of the biggest failure mode that you can have is rolling shear, of course. And you have another reinforcement, these other screws here, which are there to reinforce the compression perpendicular to the grain. There are some tables available online so that you can easily calculate how many of these you need and what is the maximum loads that you can support with your connection, as you can see here. And let's have a look more into the detail, how it works and why is it working better than normal and normal structure with beams and columns. So first of all, you have a continuous slab, and from an engineering point of view, that's better because instead of having a bending moment diagram which is going down like that, you have a continuous slab, so that and therefore you have areas in which the bending diagram is going up and reduces the one in the middle of the span. So it works better for this reason, first of all, and this is how you place it on site. Of course, it completely eliminates as well the compression perpendicular to the grain, to the fibers that you might have in these locations, which is of course an issue with timber. And this is how you place it on site, basically how you place in those long full threaded screws that we've seen before. It's very important to use a torque wrench to be sure that you are placing the screws with the right torque inside the steel to timber connection. That's always very important. And when to finish it off, of course, you place the upper column and you continue like that for the whole building. Of course, this spider connector has its own dimension, so it can be too close to the edge of the building because of these big arms which are going in all directions, 360 degrees. But you can use this connector together with the the pillar, which is another product that we're gonna explain in the next slides. You can have two kinds of slabs, so two kinds of CLT structures together with this product. So you can decide to have a continuous slab, like the one that you can see here. You can have bigger spans with this, in this case scenario, and basically you connect the CLT panels one to another with a bending moment connection, like the one that you can see down here. And in order to do that, you use steel plates, which are connected with epoxy resin, which is the Xepox in this case scenario. And another way to do the same thing basically is just by using the CLT panels down here as a continuous beam, and you can place other CLT floor panels on top of those, so that you basically are achieving the same thing, but without using bending moment connections, which sometimes are difficult to design. Of course, Rothoblaas can give you help, the technical support for connections like those ones. But you can see like that with this method, you are able to achieve spans which are not as big as the one that we saw previously, but big enough actually to have the correct span of your buildings, of course. This again is helps us to save a lot of time as well, and the main savings that we can find are, first of all, you eliminate completely the secondary structure, so you don't have to waste time on site, connecting all those structures and placing them on site. You save a lot of cubic meters of timber, and you as well save a lot of cubic meters of the building. So with the same height, you can have more stories, for example, you can have more floors, and you don't have issues with installations passing through the beams, which is always a very big concern, a very big issue in big buildings, for example. And of course, you have this nice architectural finish, which is very minimal and very beautiful, like the one you can see in the picture. Before moving on to the next product, I would like to show you a small video that helps you out understanding all these characteristics of the spider and the pillar that we're going to explain in a minute. So another you know, product that I wanted to explain to you, which is very innovative and just came out on the market, is this pillar connections. So it's very similar in a sense to what we saw before, because this one helps to get rid of the issue of the compression perpendicular to the grain, which of course is a big issue in timber structures. So basically you're replacing, you have a little steel column which is bringing all your upper forces down to the other column, and so you can achieve the same thing basically, having a structure without secondary beams and all the connections that you have for those beams. It's very similar to the building that we saw before, the Brock Commons. That's where the concept kind of came from. It was built in Vancouver. These, of course, were using they used for this project here in Vancouver all custom-made plates, which were not certified, and they have to be designed by the structural engineer, which you know, it's always very complicated. And by using this product, you have already all the values, the resistance values that you need, and it's very simple. It's certified. It's straightforward. You have the help of a technical. You have all the technical support that you need for this. And by the way, let's have a look at the spans that you had here. For example, in the Brock Commons, 4 meter by 2 meter 0.85, and as we saw before, with these innovative products, we can achieve as well, since they are engineered, very well engineered, and as well they are tested. You can achieve bigger spans as well, which can be can be useful for offices and other buildings. You can see here how the pillar works, how the connection works. You can see that here that you can place as well, you know, washer to avoid the noise from passing from a floor to the other, from a level to the other. And it's very simple and it's very straightforward, because you basically have a bottom plate, your steel little column that you have here, and an upper plate which gets connected with the upper column. So it's very simple. These are the parts that are you know, the components that are you know, are the pillar, basically, are making the pillar. And here is how you place it together with using simple screws. Let's have a look at how the load is transmitted from the upper floors, the upper stories, to the bottom ones. It's very similar as the one we saw before, because you have the load from the upper floors and as well the load of the floor here. Instead of being, you know, you don't have a CLT floor which is hanged you know, to the product, but the load is passing through the bearing here that you have from the CLT structure to the plate below. So that's why it is important, when the loads are bigger, to have these reinforcement screws to avoid problems of compression perpendicular to the fibers, to the grain. As well as we just explained what the reinforcement are for, and you have as well, if needed, an uplift resistance too, which can be very important. We have the same table so that you can verify immediately if your connection is working with the loads that you have in your particular building. And we can place it exactly in the same way like we just explained for the pillar. So you can have the continuous slab with bending moment connections like the one that we saw before. And you can see here that the spans are quite big, 7 meters by 3.5 meters. So you can achieve very, very good spans with this method here. And you know, another method is to have just single panels, and you avoid, you know, having bending moment connections, which are sometimes an issue. And I thank you very much for your time. That's the end of the presentation. I hope you liked it, and stay updated for other video lessons. And it's all for now, and thanks again.